Hello.
Hi, sir.
Yes. Let's start. How are you?
What did you say?
So you are writing tomorrow?
Yes, sir.
Yeah. Let's work on something for you, right?
Sir, can I please send you the photo of the scope?
Yes. Send it on WhatsApp. Let me see.
Yes, sir.
Hello. 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 Have you sent the scope?
Yes, sir, I'm back.
Have you sent the work?
Yes,
Have
sir.
you sent? You have sent the scope. All right.
Yes, sir.
Let's see what is it that they gave you at school so that we can discuss. All right. That's the scope for defining files, transfers, amplitude,
Yes, sir.
maximum position, yes, wavelength, and frequency. So these are just definitions. Must know frequency, wavelength, frequency, amplitude, period, wave speed. That is what we are dealing in the assignment. Wavelength, lambda, frequency, F, amplitude, period of wave, T, wave speed, V. So you must know when you are doing the calculation.
Yes, sir.
And so when they talk of superposition, principle of superposition means what? It's the algebraic sum of what? The amplitude of two pulses that occupy the same space at the same what?
Time.
Okay. That is superposition. Define constructive interference. We are just adding for constructive interference. There they are saying it's a phenomenon where the crest of one pulse overlaps with the crest of another pulse to produce one pulse of increased amplitude. So in that question paper, the pulse was underneath, isn't it? Then the other one was on. So those ones, they are not constructive, they are destructive because they are not in the same phase. They won't add up. So those are the key points that you should be noting. Like for constructive, all the pulses are above and they are all above, but they are having different amplitude. For destructive, one is on top, one is underneath. And you must know the definition of superposition. The principle of superposition as the algebraic sum. That was the answer for that assignment which I gave you for the test, that question test. There was a definition. So we are actually doing the right things. So this question paper and the scope, they are addressing the same things. They are addressing the same. Like for the example, what is a wavelength? What is frequency? What is period, amplitude, crest, a trough? What is a trough?
So can I please attend to something quickly?
All right.
Yes, I'm back.
All right. So I was just saying that these things are addressing everything which was in that question paper. For example, they are talking of the wavelength, that the bullet which is appearing there on the screen, where they are talking like the second bullet, which is saying define terms, wavelength, frequency, period, amplitude, crest, trough of a wave. You now know how to draw these things, isn't it?
Yes, sir.
Like that question which we're doing, drawing those things.
Discussing, yes, sir.
Where do you put your, the one cycle is just representing one complete wave, and then the amplitude distance from the initial point when the particle is at rest, when I was explaining that day.
Yes, sir.
Yes. And then a crest, these are those which are above the rest point.
Points, yes, sir.
Troughs are the ones which are the lowest point.
Yes, sir.
So crest is the highest point of a wave, and then the crest is the highest, then the trough they are below, which means the lowest point. So if a crest is 2 meters, and then the trough will be minus because it's below the initial point. Any question there?
No, sir.
Then explain the same, the wave concepts in phase, out of phase. For example, in phase, 2 points in phase are separated by a whole number, like 1, 2, multiple of complete waves. Out of phase, points are not separated by a whole number, multiple of complete wavelength. So in this one, when there is in phase, like for example, when we are talking of a transverse or pulses, for pulses, That's when we're referring to if the other one is on top, the other one is down. That is, the interference is what? Destructive. But if all the pulses are above, they give us constructive interference.
Constructive. Yes, sir.
Yes. Then let's go to use the relationship between frequency and period. F, you must know the formulas. So the relationship there between frequency and time is what? Is it direct proportional or inverse proportional?
Sir?
The relationship between frequency and period, is it a directly proportional relationship or it's an inversely proportional relationship?
It's inverse.
It's inverse. When you increase frequency, the period what?
Decreases.
Yes. When you decrease the frequency, the period, then the frequency what? Increase. That is the inverse. Yes. Then define a wave speed as a distance. So this one, you are just using the formula for speed. Speed is equal to distance over time. So define a wave speed as the distance traveled by a point on a wave per unit time. In other words, they're just saying distance is speed over time. Yes. So we were dealing with this formula in that discussion where we did that other short question which I sent you the previous. Use the wave V is equals to F lambda to solve problems. So we are going to use it today so that we warm up with this. So the scope is in line with what we are doing, not out. Not out. And then on a spring, what type of wave is on a spring? What type of wave? A spring.
Longitudinal.
Yes, it's longitudinal. If you put a spring on a horizontal surface, when you compress the spring, isn't it, with your hands,
yes,
it will try to push you out. Why? Because the wave is not moving perpendicular to the disturbance. Remember, by squeezing the spring, and yet the spring is on the surface, the direction is parallel. The disturbance and the movement of the spring is parallel. Your hands are parallel to the spring. They are not perpendicular to the spring. Okay. So the wave on a spring, which is experienced in a spring, is a longitudinal wave. You must know it by now. Longitudinal wave.
Wave.
Yes. And then the wave in a, like you are playing a guitar, the string of a guitar, it gives you a what? What kind of wave? When you are playing a guitar, those strings, they give you what? What kind of wave? Is it longitudinal or transverse?
Transverse.
It's transverse because your hand is pulling the string down, but the movement of the string of a guitar is perpendicular to the movement of the finger. The finger will be going down, but the movement, you see, it's vibrating. The vibration, they will be going perpendicular. So you must know for a spring longitudinal and for playing a guitar, it's transverse. So from the definition, the vibration is parallel on a spring, parallel to the direction of the motion. So on a transverse wave, it's not parallel, but it's perpendicular to the disturbance or the motion. Okay.
Yes, sir.
So these are key things to know. Frequency, we have discussed this one. Let's see another scope which we are talking about. All right. Sound waves. What type of wave is a sound wave? Sound wave is a what? The longitudinal wave, isn't it?
Yes, sir.
So know those things, those examples. If they ask you longitudinal waves, sound waves, waves produced by a spring, they are all longitudinal waves. Okay. And there are also waves of ultrasound and those sonar. The sonar, which they are talking about, they are also examples of longitudinal waves. When they talk of pitch, what do they mean? The loudness, quality, and tone. So the pitch of a sound, relate the pitch of a sound to the frequency of a sound. So pitch is the effect produced in the ear. So the pitch is directly proportional to the frequency. So once they say you have increased the pitch, you have increased the frequency. So that's what they are just saying there. These are theoretical problems. So you must just read these ones before you go for theory. Ultrasound, we said ultrasound is a longitudinal wave. Yes, ultrasound is an example of longitudinal. Where is it used? You must know the practical use of ultrasound. That ultrasound, for example, in treatment and pregnancy. So when they are scanning there, someone who is pregnant, they are using ultrasound to see the vibration. Then they can detect how old is the baby, how many months, etc. So they use that those waves of ultrasound to detect those kind of scenarios.
Yes.
Let's move to a particle. So the dual nature of electromagnetic. So by saying dual, a wave can behave as a particle can behave as a what?
A wave.
Or as a what? When they say a particle is vibrating. Remember before we were dealing about vibration of a particle. It's a particle, whether the particle is vibrating and now is it moving in the direction of propagation or is it moving perpendicularly to the direction of propagation? So a particle has a dual nature. So the dual nature of electromagnetic radiation, by dual, which means they can behave as a wave and they also behave as a what? As a particle.
Particle.
Yeah. But we'll do calculations.
So dual means behaving
in both twice. Dual it means twice, which means they are behaving as a wave and they also behave as a what? As a particle. All right. So this when they talk of particles, now you'll be using that formula. E is equals to HF, where H is the Planck's constant. You see here, the nature of electromagnetic wave as a particle. The nature of electromagnetic as a particle. So, which means when we talk of a photon is just a packet of energy found in light. So this light which we are talking about, we are saying light behaves as a what? Particle, number one, or light can behave as a what? As a wave.
Yes, sir.
Yes, that's what we are talking about. So this is dual.
It's also dual.
Yes, these are it's electromagnetic. So light is part of electromagnetic wave. What kind of light are you talking about? Visible light? Is it ultraviolet light? So it behaves as a wave. At the same time, it's behaving as a particle. Behaving as a wave and as a particle. Go where they are saying give an example of the use of each type of electromagnetic radiation. So this electromagnetic radiation which we are talking about, gamma rays, X-rays, let's go to ultraviolet light, visible light. So what they are saying they are saying the behavior of electromagnetic, like for example, light, it has the dual nature in such a way it behaves as a particle and it can behave as a what? As a wave.
A wave.
Yes. If we want to find that energy in that light, we can use that formula. E is equals to HF, where H is the Planck constant, F is the frequency. Okay.
Yes.
F is the frequency, which is the same as saying H multiplied by C, and C is a what? C is representing speed of
energy.
No, C is not representing energy, the speed of light. is 3 times 10 to the power 8. So c is representing the speed of light. C is always the speed of light. Then lambda is the wavelength of that particular electromagnetic wave. You will be given the value of lambda. Then you can calculate the energy of that particle. Get it? Hello?
Yes, sir. It's the network.
All right, so that is what they are talking about there. Or we can also use that formula of V is equals to F lambda. When you are calculating the frequency, whatever, using a light as a wave. When a light behaving as a wave, then V will be equals to F lambda, where our
Right.
V will be the speed of light, and then the frequency and that wavelength. Then we will be able to calculate some of these values, which are F, like F, you can calculate that. So if you are given the energy, you know the Planck constant is given. So let's do it in terms of calculating so that you can understand. So there's another page again. The last one. Let's see what is in the last scope. Yes. So there are two kinds of charge. They are saying all material contain positive charges, which are protons, and negative charges, which are electrons. Is there any problem with that point?
No.
That one is clear. So an object that has equal number of protons, of number of electrons and protons is neutral, which means there is no net charge. For example, 3 protons, the number of protons are the same as the number of electrons. That metal is not going to be charged, it's just neutral.
Yes.
Right. Positively charged objects of electrons are electron deficient, and negatively charged objects have an excess of electrons. Negative means it has gained. Positive means it has what? Lost. That is why they are saying, yes, from chemistry part or the periodic table when they are bonding, whenever a charge, like they say aluminium 3+, it means whenever it reacts or bonds, it will lose 3 electrons. So deficient means it has lost. And then it becomes positively charged. So positive here, it's not the mathematical one. Here, this positive is indicating it has lost. Okay. In maths, we'll be saying a positive, which means it's extra. No. For here, the positive, it means it has lost electron. The negative means it has gained electron. And then insulators, you know the definition of insulators. They don't conduct electricity, isn't it?
Yes, sir.
So basically what we'll be working with here, you must know the principle of conservation of charge. This one they ask. The net charge of an isolated system remains what? Constant during any physical process.
Yes.
So in other words, you are saying Q1 plus Q2, if you are given charges, that Q is the charge after 2 charges are brought into contact. If another charge is 5 coulombs, then the other charge is minus 3 coulombs. You add the 2 mathematically, 5 plus minus. Then you divide by 2. Then you see what is it charge now having. Then we can calculate how many electrons it has gained, etc. But we'll do it using a equation. So you never done anything about the resistance, nothing to deal with electricity resistance, ne?
Not yet, sir.
So which means the test is going to be very easy. It's the same with this one, which we want to discuss. So let's go straight away and discuss. Which means we have not done others like electricity. It means there's nothing there to do with. So let's go now on the discussion We'll be discussing while you're writing, and then you ask where you don't understand. You continue like that. Yesterday, I was saying there's no need for us to focus with maths. Not that I was saying, since it's homework, isn't it you get answers at school? Even if I don't have. Yes, so it was not a priority. We are much concerned with these things that affect you, especially your marks, like this one. It's a major thing, this one. Once we don't focus on physical science, we focus on maths too much. Maths we are already done. So let's focus here with physical science, which is at least after we are done with physical science, then we can now balance. We do maths and then, yes. For now, let's focus on this one.
Yes, sir.
Right. Then here they are saying, four options are given, are provided. So number one, choose the answer and write A to D. So let's read the question. Two pulses are traveling towards each other. Yeah. So the two pulses are traveling towards each other along a string. Okay. This is not a wave, it's just a pulse. So the other pulse is going to the right, then the other one is below there, as shown. So the question, they have different amplitude, these pulses. And these arrows, they are indicating the arrow to the right, showing you where the pulse is going to the right. Can you see?
Yes, sir.
And the arrow on the X is going to the left. So when the centers of the two pulses meet at Q, the amplitude of the resultant, which means what is now the new pulse, is going to be 1 pulse. So now we want to know what will be the resultant. Are we going to add the pulses? Is it a constructive interference? Is it a destructive interference? From what we have learned now from our definition. Okay. So let's see.
Yes.
At Q, which one will be the correct answer? Can you see which one is the bigger one from the diagram? Which one is a bigger amplitude?
Y.
Which one? And which one is a smaller amplitude?
X.
X. So when you are solving this, because they are moving in the different direction, they are simply saying, since this one is moving in a different direction, we are saying if the right is positive, isn't it? This one is going to the left, which means we assume left is what? Negative. So what we say, when these pulses meet, they are not going to be constructive, but they are going to be what?
Destructive.
Destructive. So which means the amplitude of pulse Y minus the amplitude of pulse Y, X.
X.
That will be the new pulse. That will be the new pulse. So it will be smaller, but at Q, it's not going to be bigger than this one. We expect it to be somewhere
balance
less than, but it's less than at point Q. After they've met, we are expecting a pulse which is like that now. So in other words,
yes,
it can be less than 1, but it's not at the bottom. It's not down, upwards. That's what we are expecting. So our answer there should be number 1C, Y minus X. Y minus X. Be Y minus X, 1C. So now we are using the theory that we were discussing here to answer the question. So now we are saying the frequency of a wave is defined as what? The lowest point on a wave? Is it correct?
No.
B, the time taken for one complete wave?
No.
What is the lowest point on a wave? We said it's what? This one. The lowest point on a wave. Yeah, now you know. See. At least when you talk like this, we know we are ready. So these are trough. The time taken to complete one, what is it called? Complete
Period.
wave. The period. So you find out some definitions are there in the multiple choice. When you are stuck, go and look for other answers in the multiple choice. You find the question has been asked in the long question, and the answer is there as part of the answers in the multiple choice. You just copy what they wrote in the multiple choice. When then they come, they say, define period. Instead of you to stress, you just come and take that definition. Period is the time taken for one wave, complete wave. You are done. What about the number of complete waves per second? We call this one.
It's the frequency.
Number of complete waves per second.
It's the frequency.
Is the frequency. And the number of points in one phase in a wave. The number of points in one phase in a wave, what do you call it?
It's the wavelength.
The wavelength. So our answer is C, it is frequency. The number of complete waves per second. We are talking of the second. How many cycles have we completed? So these are numbers of complete waves. How many in 1 second? So in other words, our gauge, it will be, you check your time. What you are gauging here, time. We are only checking after 1 second. After 1 second. How many of these cycles are there inside? That is the what? Frequency. Okay. So you check after 1 second. So that will be the frequency. That's how we see those. Then let's go to number C. Which one of the following do sound waves travel the fastest? Does it travel the fastest in air? Does it travel the fastest in solid, in liquid? Does sound travel the fastest in solid? Or does sound travel the fastest in a vacuum?
Is it in solids?
Why is it in solid? What is the reason? Explanation?
It's because the particles do not move all around.
In solids. Are the particles vibrating? In solids, are the part, when you are talking, let's compare in air. How are the particles of air?
They are all over.
Closely pegged or loosely pegged?
Loosely.
Loosely. So can you see that the way the particles are pegged, it's becoming small. For liquids, there's space in between, but they are not very far apart as in solids. In solids, their particles are close together compared to the other ones, which are air and liquid. So in solids, the particles are very closely packed.
Okay.
That is the reason there. Compared to liquid and air. All right. Then which one of the combination below concerning pitch and loudness is correct? Let's compare pitch and loudness. Pitch is the frequency. Pitch is the frequency. Pitch is the amplitude of vibration. Pitch is the speed of vibration. Which one is correct along the pitch only here? Let's start on the left side before we go to loudness.
Pitch is the amplitude of vibration.
Pitch is the what?
Amplitude of vibration.
Is that correct from our definition? Pitch, does it not have relationship with frequency? And loudness, is it not the amplitude of vibration?
Oh, I mixed them up together, sir. Ish.
Yes, so pitch is the frequency. So pitch is the frequency. And then the loudness is the amplitude of the what?
The
Vibration.
vibration.
Yes. So pitch is the frequency. And then the loudness, they are talking about how far this amplitude, the length where it's reaching here, amplitude, that wave. That is how loud it is. The amplitude
Yes,
of it. Yes. So the higher the amplitude, the higher the loudness. But the frequency, which means it's just the pitch. They are referring to the pitch. So the amplitude, so our answer is A for number 1.4. So let's continue. Our answer is A for 1.4. Then let's go to the next one. Consider the following statements. Ultraviolet radiation. It cannot be reflected. It has a longer wavelength than gamma rays. And then it is radiated from the sun and may be harmful to humans. Which statement is correct there first? Which statement is correct in terms of ultraviolet? Let's go to point number 3. It is radiated from the sun and may be harmful to humans. Point number 3. Yes, radiation. That's why our skin prevents us from radiation from the sun. Cancer. So which means ultraviolet radiation may be harmful to the one, to the humans.
the humans.
That's why the use of the ozone layer, remember, it prevents radiation. That's why when they say if the ozone layer is removed, which means the sun will hit us directly. Okay.
Yes, sir.
So,
Yes, sir.
which means point number 3 is there. We want it. So we are eliminating others. So we want something that is point number 3. So
Yes,
let's
sir.
check. Let's check. It cannot be reflected. All right. And
Yes, sir.
it's longer wavelength than gamma rays.
Please.
So now let's compare number 2. So which one? Which order? We have what we call radio waves, microwaves, violet waves, ultraviolet waves, X-rays, gamma rays. So I made a mnemonic there, RAMIVAX-GA, meaning radio waves, microwaves, violet waves, ultraviolet waves, and X-rays for X and gamma rays. So now check where the U is and check where the gamma is. And how does the wavelength increase? So the question now is saying it has longer wavelength than gamma ultraviolet. So which one is longer waves? Is it correct?
No.
No. So which means our wavelength increases from this side. Our wavelength. So in other words, what we are saying the one that is the longest wavelength is the gamma, isn't it? Before the what?
Yes,
before the ultraviolet, the U. Before the U. RAMIVAX-GA. So the X, they are representing X-rays. So ultraviolet, it's here. and this is the direction of my wavelength. So wavelength is increasing from left to right, starting from radio waves. Can you see where the radio waves
Yes, sir.
are? They are very
Yes, sir.
short, the radio wave, compared to the gamma and the X-rays. They can go very far. Okay. So
Yes, sir.
that's why we have eliminated the answer 2. So 2 is out. So it automatically tells you this is out, this is out. So which one are you left with? 2 is out. Can you see everything comes clear? Which one is the answer?
Yes, sir.
The answer you automatically see, you have got an idea now that the answer is C because 2 is out. So you must know these rays, which ones? Microwaves, these ultraviolet waves, X-rays, gamma rays, how do they increase? Which ones where do they increase the direction from left to right? You must know that order before you go, so that in the multiple choice they ask this kind of question. Like in
Yes,
this
sir.
case, if you only knew that no, X-rays are bigger than, they have a greater wavelength than ultraviolet waves. Gamma rays, they have a greater wavelength than ultraviolet waves. Already your answer is out because you know that number 2 is out. Number 2 is wrong. Okay.
Yes, sir. So you said it's Rami.
Or I just made a mnemonic which I used to use, Ramivax-Car. Then you can just pick just Ramivax-Car, then you see which the wavelength is increasing from left to right. So in our case, they said it is longer wavelength, ultra, it is longer than gamma. But on our answer, we are seeing that no, gamma is longer than ultra. Can you see what I mean?
Yes, sir.
I just drew like this. So you know what it will be means. So these are U, which means ultraviolet, X-rays, gamma rays, microwaves, and radio waves. Any problem?
No, sir.
So which means gamma rays is longer than the violet one, ultraviolet one.
Waves.
Okay, so your wavelength is increasing. This is increasing from left to right, increasing the wavelength, lambda. So once you know that gamma rays have a longer wavelength, so which means ultraviolet has a longer wavelength than gamma, it's a wrong answer. Then you can eliminate, you say, this is wrong answer. This is wrong. This is wrong. And then you check again the other one where they are saying wrong. Automatically your answer is out without stress.
Yes, sir.
Then the rod requires a negative charge after it has been wrapped with wool. Which one? So a rod acquires negative charge. So negative charge, what did we say about negative when it comes to this thing of transfer of electrons? Negative means
It has gained.
negative, it's a gain.
Gained.
The gain or a loss?
It's a gain.
The gain. All right. So the rod acquires a negative. So this is the rod that acquires negative. Okay. So now we want to know if the rod acquires a negative, the negative charges are transferred from what to what? So that's what we want to know. So the rod acquires negative charge after it has been wrapped with wool. So we have wool and the rod. We have wool and the rod. So the one that gained which means it becomes negative. So the
Yes,
answer, which one can it be our answer? Does it mean positive charges are transferred from the rod to the wool?
Can I please just read through the ABCD?
Okay. Take your time and tell us what could be our answer.
So is it D?
Is it D? The negative
Yes.
charges are transferred from wool to the rod. Yes, it's D. Why? Because the rod has acquired a negative one charge.
Charge.
Yeah. So these negative charges, which it has gained, in other words, we are saying these electrons, it's just a confusion. What this rod acquires electrons, in other words, they are saying it has gained what? Electrons, this
Electrons.
rod. So if it has gained electrons, which means these negative charges, these are electrons that have been gained. Where has
Yes.
they been they've been gained from where? It was from the wool to the what? To the rod. So in other words, you are just checking the answer that is wool to rod. So we have two answers there, wool to rod. We have this one, wool to rod, wool to rod. Because we said negative charge means you have gained, isn't it?
Yes, sir.
Yes. So now, if you have gained, if the rod has gained, which means it's to the rod from somewhere, which means it's from wool. So you check the answer from wool, which means it's C and D. A is out, B is out. So we are left with C and D. Now we are saying now, positive charges are transferred from wool to rod, or is it negative charges transferred from wool? What is it that it gains? It gained negative. So negative charges have been transferred. Then you know that C is what is out. Then the answer is
Yes.
D. Yeah. Can you see how we are reasoning?
Yes, sir.
So this is how you eliminate. You first pick a stance, eliminate some, automatically your answer will come. Automatically your answer will come. Right. All right. So we are here now. This is you did not do electricity, isn't it?
No, sir.
So let's leave it. Not coming. Not coming. Let's leave it. Let's go to question number 2. Can you see what is happening there at question number 2? Two girls are standing opposite,
yes,
at opposite ends of a rope. Each makes a pulse of the same speed. The pulse A with an amplitude of 4 centimeters moves to the right. So pulse A with an amplitude of 4 centimeters moves to the right. And pulse B with an amplitude of negative, so which means negative underneath. So which means there's another
yes,
one which is moving to the left. The pulses meet at C,
yes,
just like the one which we are calculating. So already you have been told that this is negative. Let's just make it bigger. We just say it's -6. And then this one, just make it big. We say it's 4 centimeters. So they've met here. This one is -6. Why is it -6? It's down, isn't it?
yes, sir.
This one is 6 centimeters. So when they meet here, where do you think is the resultant going to be? Is it going to be up or down? When they meet at
A
C?
bit down.
Yes, to be a bit down. With how much? Now you know.
-2.
-2, yes. Centimeters. Don't forget the unit. So this one at C, the amplitude here, you are expecting negative. So which principle are they talking? Which phenomenon observed by the two learners at point C? What do you call that phenomenon?
The rest position.
No, the phenomenon. Now they want the phenomenon, which means the principle at C, which they are going to observe. What do you call that? Principle of superposition.
Superposition.
Yes, it's principle of superposition. That's what they are going to observe, whereby those pulses are going to subtract each other. So what they are going to observe is what we call the principle of superposition.
Superposition.
So they are going to observe the principle of superposition. That's what they are going to observe. Principle of superposition. What does the principle of superposition say from the notes? Says what? Still remember? The algebraic sum of amplitudes of two pulses that occupy the same
position at the same time.
Yes. So it's the algebraic what? Sum, which means algebraic, which means we are adding these things algebraically. For example, what do we mean we are adding algebraically? We are saying 4 plus bracket 6, because it's adding. Sum, it's a plus. Sum it's representing that plus. That is the algebraic sum. Why is it algebraic sum? That's where we apply the algebra. Positive times negative give you what?
Negative.
That's where the algebra comes in. So first is the algebraic sum of the amplitudes of the two pulses that occupy the same space at the same time. So they're occupying the same space at the same time. Then we find the algebraic sum. So the 3 marks are writing. 1 mark, the principle of superposition. Then you say, this is the algebraic sum of the what? Of the amplitudes of the two pulses that occupy the same space at the same time. Yeah, done.
Yes, sir.
Then let's go to the drawing. Draw the diagram to show the resultant pulse when the two pulses meet at C. Label the pulses clearly. So when now at C, we are only interested with the pulse at C, isn't it?
Yes, sir.
So the pulse at C will be just like. Then what is the amplitude?
-2 centimeters.
-2. 2 marks. Then you indicate that this is the amplitude. You must indicate that this is the what?
Amplitude.
The amplitude must indicate that that is the amplitude. Must indicate that that is the amplitude. Then you put the unit -2
centimeters.
Okay. Name the interference. So they are saying now name the interference. Amplitude is -2. We have put it there. Name the interference that takes place when the pulses meet. Is it constructive? Is it destructive?
Constructive.
When these pulses meet, is it constructive? Is it destructive? And
when
why? When they meet,
both
A and B meet, do we form at C? Are we going to form a constructive or destructive interference? At C, the one which you have drawn here, that resultant, is it constructive or is it destructive? The interference, is it constructive or is it destructive?
It's destructive.
Why is it destructive?
Because it has it has only one pulse at the bottom.
Even constructive, you get one pulse at the bottom. The resultant, you get one. The reason why it's destructive is because the other pulse is moving on top, and then the other pulse is moving what?
At the bottom.
At the bottom. So when the two pulses meet, which is the one on the top and the one at the bottom meet, we form a destructive what? Interference.
Yes, sir.
Yes, so you must know that. If two pulses are both moving up like this, if two pulses are both moving up like this, you have a pulse and then going to this side, going this direction. Then there's another pulse which is going to meet like that. Both of the pulses, in which direction are they moving? So it's also a matter. You must also know which direction they are moving. If this another pulse is moving in the same direction to be constructive, and all of the pulses are in the same phase, which means they are moving at the top. If they are out of phase, remember there was in phase and out of phase. Out
Yes,
of
sir.
phase, it's below, which means like that pulse which we are having, like that. They are not in the same phase. This one is going this direction. So when they meet, they cancel out these pulses. That's why we are saying they are destructive. Instead of us forming a bigger amplitude, we are forming a smaller amplitude than any of the two amplitudes. Check -2, it's even smaller than 4 and 6. So we have destroyed the amplitude, so it becomes what? Destructive.
Yes, sir.
Yes.
Yes.
You don't even have a bigger of any of the two. Destructive. Top and bottom, they cancel out. So here, you must know it's a destructive interference. The destructive interference.
Yes, sir.
It's destructive interference. Then you get your mark for that. How will the amplitude of the pulse be affected after passing point C? Write down increases, decreases, or remains the same. How will the amplitude of a pulse at A be affected after passing point C? Increases, decreases, remains the same. Can you see the amplitude of A? It's how much?
4 centimeters.
4 centimeters. So after passing C, does it remain 4 centimeters or it decreases?
It decreases.
It decreases. So it's only at C where there is destructive. Then each of the pulse, it continues moving in that direction at the same one.
Time.
Not at the same time, but at the same amplitude. So after the destructive interference, pulse A will still have the same one, amplitude. So the answer is remains the what?
The same.
The same. You get the logic?
No,
But
sir.
I said after the pulses meet, each pulse continues in each direction with its amplitude.
Yes,
Hello?
sir. Yes,
Yes.
sir.
So remains the same, which means it will remain 4 centimeters, and the other pulse B will remain 6 what?
-6 centimeters.
Exactly. That's what we mean. They are not going to be stationary. Each pulse will continue moving in its direction at that amplitude, which it was moving with initially. Initially, it was 4 to continue with 4. Only at Q, that's when there is destructive interference. Any question?
No, sir.
All right. Then let's go to number 3. The diagram below represents a water wave moving from left to right. The time between the two consecutive crests is 0.5. So the time between two consecutive crests is 0.5.
5
So,
seconds.
yeah, 0.5 seconds. So in other words, to complete one oscillation, that's what the time they've given us. They've given us, when they talk of a crest, which means the time to complete one oscillation. So from here, it's a crest. Then if I reach here, another crest. So the time taken for me to repeat this pattern. So I go down, go up, like that. Now I'm repeating. Before I repeat, which means I've completed this. It's a cycle already. This one. It's already a cycle. So to complete one cycle, it's taking me how many seconds?
0.5.
0.5 seconds. So 0.5 seconds to complete one number of cycles. But the frequency, it means per second. So if this is 0.5 seconds, 1 second I would have completed how many cycles? It's another second. 1,
2 cycles.
So my frequency will be how much? Because we said cycles per second. So now from there to there, we have now 1 second. And I've completed how many cycles? 2. So that is what we mean by hertz.
2.
That's what we mean by hertz. Means it will be 2. What type of wave is water wave? Water waves are what? Are they longitudinal? Are they transverse? Water.
Transverse.
Why is it transverse, a water wave? When you swim in the water, you are moving forward and your disturbance is where? Where is your disturbance going? When you swim in water, you are moving forward, but your disturbance, which you are putting with your legs are hitting where?
The water.
So are the legs going for in the direction of your motion, or the legs are going perpendicular to your motion?
Perpendicular.
They are going?
Perpendicular.
So what kind of wave is it? The wave that is perpendicular to your motion. Your legs are going up and down, up and down, up and down in water while you are swimming. And your hands, when you are swimming, it's getting inside the water. The other hand, it gets inside, you push, the other hand gets inside. How is that one? Is it in parallel or is it perpendicular? The way your
It's
legs
parallel.
are parallel to the motion. Isn't it in water, your legs? This is the water. You want to swim going this direction. Your legs are hitting up and down while you are swimming. Up and down. They are hitting the water up and down. And at the end of the day, we are seeing yourself moving this side, the motion. You are perpendicular. But the movement, like what diagram that we drew that other day, it was like this. And your movement causing waves like this. So what kind of wave is this? Is it a longitudinal or a transverse wave?
Transverse.
Write the amplitude of the wave. How do we get the amplitude? From what is given, isn't it? So from here, our diagram, tell me what is the amplitude. What is the amplitude of the wave? Calculate for me the amplitude of the wave on this diagram. I just may looking, tell me the amplitude. Can't take 1 minute. The matter of just looking, tell me the amplitude is because of 1, 2, 3.
So the question, what did it say?
What is the amplitude? We are doing number 3.2. What is the amplitude?
Can I please see the diagram?
What is the amplitude?
2.5 meters.
That's the amplitude. Hello?
Yes, sir.
You said what is the amplitude?
2.5 meters.
Yes, then you are wrong. You are wrong. You must analyze your diagram. Let's analyze the diagram. We are saying amplitude is the distance, the maximum distance from origin. This is your movement of the disturbance up and down. This is not the first time we are drawing this diagram. That's the one which we discussed that day. So some things you must put for yourself to analyze. There must be this line which is representing time, or it can represent wavelength. But if you want time to reach 2 successive crests from B to D, then you can put it as time, no problem. But it's not always time, the x-axis. So what we are saying, amplitude is the distance, the maximum from there to there. That's what we are looking for. Don't take what you are given, then you say it's the amplitude. So what is the amplitude? We want the distance from only this one. What is this distance? That's the amplitude. The maximum from the origin. This line is representing the origin. So from the origin, initial or rest of the particle to the maximum, what is the amplitude? So tell me now if you have understood what I'm saying. That height, this height from the origin, what is it?
1.25.
Why is it 1.25? What did you do?
Because I divided the 2.5 because they are two different lengths from the rest of position to the top and to the crest and to the trough.
So this height which you are given, it's both from crest to trough. You are given from crest to trough. So this is the trough to the crest. This is the maximum. There is a height of 2.5, so which means it's halfway. Half of 2.5 is 1.25. Get the logic? So in other words, it's 2.5 meters. You divide by 2 because it's half of those things. So you divide by 2. So 1.5, 2.5 divided by 2 is 1.25 meters. That's our amplitude. Any question? Any question there?
No,
yes,
sir.
That is our amplitude. That is our amplitude for number 3.2. That is our amplitude for number 3.2. Then from the number 3.2, they are saying now define what we call a wave.
The term wavelength.
Yes, what is wavelength? The distance between two successive what?
Point in a phase.
Yes, distance between two successive points in a phase. So a phase, which means where you are repeating. So that is a wavelength. Like for example, here we were told 2 consecutive crests takes 0.5 seconds for 2. So here we are saying a wave is the distance between 2 successive crests. That is the wavelength. Which ones here are the successive crests? Successive points in a phase. For example, from B to what?
To F.
B, F are successive points in a phase. In a phase. So that is what we call wavelength. So can you see we're applying the theory which we're reading from your scope?
Yes.
Yes. Let's go to 3.4. Determine the wavelength of the wave. Now let's calculate that wavelength. So we said the distance between 2 successive what?
Points in a phase.
So what is that distance? What is that distance?
3 meters.
Why is it 3 meters? 1.5 times?
2.
There is one. So I told you one number of complete wave. Just a complete wave starting from B. Before it repeats itself, so I go down, I go up. Now I'm repeating myself, going down again. So already I've completed a successive wave. So we know these points are symmetrical. If I know this is half, this length are equal. You did similarity and congruence. So you know that if this from there to there, 1.5, is the same length with this one, 1.5.
Yes, sir.
So you add the two. So which means the wavelength now, your lambda is equals to how much? 3
meters.
3 meters. That is your wavelength. But your frequency, we say the number of this wavelength in 1 second, not in 0.5 seconds. So if from there to there, it takes 1 second. So you calculate that after, 0.5 seconds, after 1 second, how many of these waves, number of complete waves you'd have made? You'd have made 2, because I'm going to repeat that. I go up. So from there to here, I'm taking 0.5 seconds. And also, which means from there until here, I'm going to take another 0.1.
5 seconds.
5 seconds. So from our definition, they said the number of these cycles which we are drawing. So this is wave number 1, wave number 2. So I have 2 of these over what? 1 second. I have 2 of these waves for 1 second. So your frequency automatically becomes 2 hertz, isn't it?
Yes, sir.
I give you you already know a second. So whenever they see the unit for hertz is what we call that number, cycles per second. So which means our answer, it will be automatically 2 hertz. That becomes your frequency. We have calculated the number of cycles. 1. I reached it. Now I'm repeating myself. Down, up. What is the time? Time, 1 second. So always make sure that the time to convert to hertz, it will be per second. Always it will be per second. Then you know that is your frequency. Any question?
Yes,
any question? Any question? So the question now is saying Name 2 points on the waveform above that are in phase. Points that are in phase, which are repeating after every wave. Which points are in phase? Which points are in phase? Which are repeating every time? Which are in phase, which means they repeat every time.
Say point B and J.
Point B and
J.
No, they are not repeating. Like in phase, let me give you an example. A, it repeats after how long? Which are in phase? One cycle?
0.5 seconds.
I can't hear. Then there's E. So after A, if I complete one cycle, I'm at what? I'm at E. Can you see it?
Yes, sir.
After one cycle, I am at E. So which means points that are in phase, I have A, you write E, I'm at E. These points are in phase. Then I complete another oscillation again, which is the second one. Number 2. I am at what?
I.
So A, E, I are in phase. Right. A, E, I are in phase. Then let's check another one which is in phase apart from A, E, I. Let's check another one which is in phase apart from A, E, I. Let's use a different color. Let's go to B. Let's go to point B. Let's go to B. Can you see B?
Yes, sir.
Right. Let's have a point starting at B and it's repeating itself. So B, I make an oscillation down. I go up. I'm at what now? Before
F.
I repeat myself at F. So you write yourself. B, now we're at F. So from F, I go to what point? Tell me.
To H and then to J.
Then which letter am I going to write? Which are in phase?
J.
That's how we are doing it. Can you see?
Yes, sir.
So A, E, I are in phase. B, F, J are in phase. Isn't it?
Yes, sir.
B, F, J are in phase.
Phase.
Then let's take another ones which are in phase. Let's see again. Let's go to D. Let's go to D. Let's use another color. So we are just checking points which are repeating after some time. That's what you're just doing. You exhaust all the points which are repeating. Let's start at what? At D. Let's go to D. This is our D. Let's draw. From D, we go up. This is half an oscillation because I've gone up, then I come down. So D and H are in one.
In phase.
Since I don't have another point where I can go down and record here, so I can end with 2 points, D and H, allowed, because I don't have another point put there. So I will end with D and H. So I just end D and H.
H.
D and H, they are in phase. They are repeating. But there is no that third point again, okay, which I must record. So
Yes, sir.
let's go to another one. We can maybe go to C. Let's go to C. Use a different color. This time let's use blue. Let's go to C. Yeah. C. C. From C, now we draw. Which point I go down from C? I go up. Then I go down. So now I'm repeating again. So which point? C and what?
And G.
C and G are in phase. So you write C and G. Since there is no another point which I should write, which means I'm going to go up, then I start going down. So here there is no that other third point. If it was there, I would have written it. So it's just C and your G are in phase. A, E, I, there are 3 points. B, F, J, they are what? In phase. So pick all the points which are in what? Phase.
In phase.
Don't just write one. Pick all the points which are in phase.
Phase.
Any question? Any
Sir,
question?
I'm looking at the scope. Can you please give examples of out of phase?
The ones that are?
Examples of out of phase.
All right. All right. So you are talking of what? Examples of? Hello.
Out of phase.
No, these ones are in phase. They are repeating after every period, which means this point and that point, they are repeating after every cycle. So points which are not repeating after a cycle, C and E are what? Talk about
phase.
C. Is C and E in phase?
Yes, sir.
No, C and E are not in phase. Are they repeating after a cycle? C and E, are they repeating after a cycle?
Oh, no.
No, it's not a cycle that way. So those points are what? Are not in phase. Then talk of E and G. Are they in phase?
No.
E and G, they are not. They are not repeating after one complete wave. So the points that are repeating after one complete wave are the ones that we call in phase. Then the points that are not repeating after one complete wave, then they are out of
phase.
phase. Have you understood it? E and
Yes.
F. E and F, are they in phase or out of phase? Out of phase.
Out of phase.
Yes, out of, because the wave is not complete. It's not a one complete wave. The quarter
Cycle.
can be it may be a half cycle. But the ones that are in phase are the ones that are completing the wave. You get it?
Yes, sir.
Let's go to, so I think you answered. So for example, D and C, for example, I and J, that they are out of phase, those points. There is no complete cycle there, which is, there is no complete cycle. It's either a half cycle, a quarter cycle. They are out. But the ones that are coming after every point, then you name them. And these ones are in phase, those points. They are repeating each and every time after a complete wave. That's why I was doing those waves for you. So now they are saying name 2 points that are in phase. What was the time taken for 4 crests to pass? a certain distance at a certain point in the path of the wave. So the time taken for 4 crests to move past a certain point in the path of the wave. So which formula are we going to use?
T is equals to 1 over F.
T is equals to?
1 over F.
Okay. Then what do we do now if T is equals to 1 over F?
We substitute the
1 over F, yes. Then what do we do?
T is equals to 1 over F. And then we substitute the letters to the numbers.
Yes, let's substitute. And here the question is saying the time taken. Complete what? Is that what? What was the time taken to complete 4 crests?
For crests of the diagram that we were just doing right now. Hello?
Yes, of this diagram that we are doing now, the time taken to complete 4 crests. What is that time? Was here on the question, they said the time between 2 consecutive crests. The time between 2 consecutive crests is how much?
0.5.
Yes, 0.5 seconds. So that is the time between 2 consecutive crests, 0.5 seconds. So we said if 0.5 seconds is between 2 crests, the time between 2 consecutive crests, 0.5. So that is what we said from here. The crest, we move, we touch another what? Crest. Already a wavelength. 0.5 seconds, isn't it? It's already a cycle this way. So in other words, they are just saying this. To say to complete a cycle like this. Then I repeat a cycle like that. I take about 0.5 seconds, isn't it? Just to move in this pattern before I repeat. Then another 0.5 seconds to complete up to here, isn't it?
Yes, sir.
That's why from there from here to there is how many seconds?
1 second.
There's 1 second. Put your distance, 1 second. So from there to there, it's 1 second. So tell me now, what is the time taken for 2 successive crests? Let's calculate for 2 successive crests. So which means I want to move. So we are agreeing that from there to there is 1 second, isn't it?
Yes, sir.
1 second. The unit for seconds, just an S. Don't put another unit. Just second, that's 1 second. Then S. Then S, small s, 1 second. That is the distance up to there. Then we say, now, what is the time taken from this crest to complete 2 crests only? This is 1 crest. Now 2 crests to come to here. I must end there so that I cover these two crests. For me to have moved that route from there, come down, up to I reach there. I've covered how many crests have I covered now?
2 crests.
2 crests. What is the time up to this point? What is that time up to that point?
1 second.
1 second from where to where?
From the first crest to the last one, to the second one.
Yes, 1 second is measuring from here to there. That is 1 second.
Crest.
1 second. So what is the time here? T is equals to 1 second. So here T is equals to what? What is the time?
0.5.
How many halves are these ones? So you have this first half cycle. Then we have another half cycle here. Can you see this half cycle? Here, the half cycle, isn't it?
Yes, sir.
Then we have another half cycle here. Half cycle. Then this is another half cycle. So how many half cycles in a second? We are having 1 half cycle. This is 2. This is 3. This is 4. So what is each time interval in each cycle? How many minutes each cycle? There are 4 parts. And those 4 parts we are dividing by 0.1. 1 second
5.
divided 1 second divided by 4. These are the 4 parts. Part 1, part 2, part 3, up to part 4. We are spending 1 second. We are spending 1 second. So the question is, each part, how many seconds? I mean from here to there. How many seconds from here to here? To complete this half cycle, I make how many seconds?
0.5 seconds.
It's not 0.5, but it's what? 1 divided by 4, is it 0.5?
No, sir.
So what is it? There are 4 parts. 1 part, 2 parts, 3 parts, then 4 parts. Now I've completed the 1 second. So how many seconds have I completed in total? For each phase?
0.25.
Yes. So each part is taking me 0.25. To move this crest, only 1 crest, just move from there to just move from here. Just move from here to there, the red line. Just move this red line. I have moved. I spent how many seconds?
0.25.
Then from there to reach here, how many seconds in total?
From
here to there, 0.25. To where the red line is, how many seconds so far?
0.5.
0.5. Then for me to complete 2 troughs, 2 crests up to there, how many seconds?
1.25 seconds.
0.5. Where are you getting 1.2? Plus 0.25. We are adding 0.25 each time. Our line is here. We said 1 trip, half trip is 0.25. Plus another half trip, 0.25. We're at 5, which is this one, 0.5. Now we are adding another half trip, which is 0.5 seconds, 0.25 seconds. Then for us to reach this 1 second, we are not going to add it. because we said we want to complete 2 tracks. These are the 2 tracks. So what is the total time to complete 2 tracks?
0.75.
Yes, not 1 point, 0.75. I have completed 2 tracks. Now, the question is saying, you want to complete how many crests? No, I have completed, 2 crests. And here the question is saying, you have to complete how many crests?
4.
So what are you going to do to the 2? These are 2 crests. So 2 crests, you are spending, for 2 crests, you are spending how many seconds? 0.21, 0.75
75.
seconds. So for 4 crests, how many seconds am I going to spend?
We're gonna multiply 0.75 by 2.
By 2. So for 4 crests, which means I'll multiply by 2, that's when you get the 1.5. By 2, you get 1.5
Seconds.
The time taken for how many? 4 crests. So did you see how we're reasoning here?
Yes, sir.
Yes, this is how you reason. You are checking your diagram. You see, to complete 1 cycle, what does 1 cycle mean? It's to go up, come down. Before I repeat going up, it's already a cycle. So the answer there for 4 crests is 1.5 seconds. Now calculate the speed of the wave, 3.7. So what information are we given, which we have now? Do we know the wavelength for this wave?
Yes, sir.
Do we know the wavelength for this wave? What did we say was the wavelength?
3 meters.
The wavelength was 3 meters. And what was the frequency? The one which you just calculated now. Frequency, we know. That how many cycles per second did we calculate? There were 2. Didn't we get 2 complete waves in 1 second?
Yes, sir.
So 2 complete waves in 1 second, it means 2 hertz. That's what it means. So you are completing 2 complete waves in 1 second. In 1 second, because they said from B coming back here, it's a 0.5 seconds. It's 1 complete wave. Then if I make another wave, I come there, it will be 2 now, complete waves. So which means the time taken from there to there is 1 second. But how many complete waves are inside the 1 second? There are 2 complete waves. That's why the frequency is going to be the number of waves 2 over 1 second. So I'm having 2 waves per second. That's why the answer is 2 hertz. It's coming from the graph. I'm having 2 complete waves in 1 second. That's why the answer is 2 hertz. But the question is saying the wavelength, 1 wavelength, which we calculated here. We said wavelength is from there to there, between 2 successive crests. Distance between 2 successive crests is wavelength, which we calculated as lambda is equals to 3 meters. And we have our frequency, which is 2 hertz. So we combine that information for our formula, which says V is equals to F what?
Lambda.
That is the formula. We are looking for speed. So speed is equals to the frequency multiplied by the wavelength.
Wavelength.
your answer, the unit of speed is meters per second. So then you get 3 times 2, 6. Then it's meters per second.
Second.
Any question? How we are approaching these things?
No, sir.
Everything is coming from the graph. Everything is coming from the graph. Yes, that's how we are approaching this problem. Everything is coming from the graph. Okay. Let's move
Yes,
on.
sir.
Let's move on. So we found the wave speed, the speed of the wave, 6 meters per second. We are done. Let's go to 4.1. They are saying a sound wave is produced by a source placed. A sound wave is produced by a source placed a certain distance from a building. So the source, sound source, and that is the distance from the building which is indicated. The echo reaches the source after 8 seconds. So the echo reaches the source after 8 seconds. The speed of sound in air we know is 340 meters per second. Define longitudinal wave. What is a longitudinal wave?
A wave in which particles of the medium move parallel.
Yes, excellent. They are moving parallel to what?
To the direction of the wave.
To the direction of the wave. Yes, you are right. Or in the direction of the motion. That's correct. Right. So calculate the distance between the source of the sound source and the building. So the distance, we are not given. So the echo reaches the source after 8 seconds. And we are told that that sound wave is produced by the source. Then the echo reaches the source after 8 seconds. Then we want to calculate that distance. Which information is going to help us?
The speed of sound in the air.
The speed of sound in the air, which is correct. Yes, the speed of sound in the air. And what about the echo? What do they mean by echo? Yes. Remember from the multiple choice. Echo, what does echo tell us? When they say echo is the source. From the source after 8 seconds, what can we get that information? Like 8 seconds, it's what? What will be the frequency?
8 hertz.
Hello?
Hello?
Yes, I'm referring to, like they are saying, echo. What was the time and what is the speed? What is echo? This word echo.
It's the copy of the original sound after a certain period of time.
Excellent. So you see these problems, they want you to think a bit. So, which means what is happening there? The sound goes to the what? Building. Can you see?
Yes, sir.
Then from the building, the echo comes back. So, can you see what is happening?
Yes, sir.
Yeah. So the sound is produced by the what? By the source. Goes in this direction. This is the original what? Sound.
Direction.
Then the echo, that is now the duplicate sound of what you have already said. For example, when you say come, then that come is reflected back. You hear it back after 8 seconds, which means the original sound went first. This is now the reflected one, the echo. So in other words, the actual time, it's the time taken to reach to the building, not the echo. You get what is happening? The echo, the time taken for the sound to reach the building, because you are calculating the distance between the sound and the source and the building, isn't it? The distance. Yes. So we want to know, we are given the speed of sound in air. We want to know only the time taken from here to there. So we are only taking this half, this first half only, since we only want the distance between the source and the building, not the total distance of going to the source and the building and coming back. Okay? We only want only the distance in between. So which means the time which we are going to use, the time is going to be equals to 8 seconds divided by what? By 2. That's why our time taken for this sound to reach the building is 4 seconds. Yes, it's half the time. Because what is coming back now is no longer the sound from the source, it's the what? The echo. The duplicate, like what you are saying, yes. So this keyword, you must see it in physics. Physics, it's a very key word because echo, it means to and from. So to and from takes 8 seconds. What is the distance of just going to? It will be 8 divided by what?
Yes.
By 2, which is 4 seconds. Okay. And from what we have been doing before about mathematics, now you come and use your formula now. I always give my learners this formula if they forget in a test. How to solve. Just draw this DSTV like this. DST. Some they would say it's a formula DSTV, but the V we don't consider it. If you are looking for distance, it's speed times what? Time. Distance, this one is speed times time. D
speed
is
multiplied by time.
Multiplied by time. And if you are looking for speed, S, you now say D over what? Over T.
Over time.
And, yes. And if you are looking for T, this T on the right, then you say it's equals to D
over S.
That's how you interpret that table, DST. Okay, DST. For you to remember it, you just say DSTV, then you leave the V out. So here we are calculating the distance. We are calculating the distance, which means the distance is speed times what?
Times time.
Speed times time. What is our speed? Our speed is what? The speed of sound. The speed of sound in air is 340 meters per second. So then you write that the distance which you are looking for is equals to speed, which is 340 multiplied by the time taken is
8 seconds.
Then you know your final answer is in meters. Since your units are meters per second, then the seconds they cancel, you are left with meters. 4 times 0, that's 0. 4 times 4, 16. 6 carry 1. 4 times 3, 12 plus 1, 18. That is the distance between the source and the what? The source and the
echo.
No, the source and the building, not the source and the distance between the source and the
building.
Yes. The echo, the reason of the echo, it means the time taken for the sound to go to the building and the time taken for the sound to come back from the building. So that period takes 8 seconds. But as we are only interested with just the distance between these two, so I'm not interested about the return. So I only use the time taken just to go to the building so that I can calculate the distance. The speed of sound is still the same. The speed of the sound returning and the speed of the sound when it's going is the same. So watch out for these tricks. Okay.
Yes, sir.
Let's move on. Now we've calculated the speed, the distance. Name the property of sound wave that influences pitch. We have done this in the multiple choice. What influences pitch?
Frequency.
Yes. I know, you remember. What influences pitch is frequency. So here it's your frequency, and you write it in words. Frequency. Words. F. Frequency. All right. Which of above which frequency is a sound wave classified as ultrasound? Above which frequency is sound wave classified as ultrasound? For a sound wave to be classified as ultrasound, it must exceed 20,000 hertz. So, yes, any sound that exceeds a frequency, if it exceeds a frequency of 20,000 hertz, then we call it its ultrasound. Ultrasound. 20,000, 20 kilo. Kilo means multiplied by 1,000 kilohertz. So that is ultrasound. So you must know. We call it ultrasound because it has exceeded 20,000 hertz. Name one use of ultrasound in medical treatment of patients, like what we are doing in the, what is it, in your notes. One use for medical treatment.
The pregnancy testing.
Yes, the pregnancy test. So you must mention those ones. Then you get your tumor. So you must know those things on the web. You read them again. You will see from left to right, starting with radio waves, microwaves, ultraviolet waves, X-rays, gamma rays. The wavelength is what? Is increasing from left to right. So you must memorize those so that you can solve multiple choice problem. And this, yes, especially everything on that scope, theory, you must get it. The calculation part, that is what I was assisting you with here. The reasoning, which you might not find on the theory, these things for reasoning, they need you to see someone helping you where we are drawing everything. 4 cycles, 4 crests, you see where the full cycle is ending, like what I was showing you. Right. Let's go to number 5. Let's go to number 5. So we have different waves. Wave BA, there's a frequency and an energy. So this is where we are talking of electromagnetic waves, where they behave as a what? As particles. So a particle has energy. Whenever they talk of particles, now we have energy. And the formulas that we are using now is now E. We are no longer using V is equals to F lambda. E is equals to what? H what? E is equals to H F, which means Planck's constant multiplied by the frequency. We are no longer using
F.
this formula. Yes. So E is the energy of the particle. H is just a constant, which we are just going to multiply. Constant means a number. Then frequency, it changes. And you see the frequencies are changing here. So depending on the question, you substitute the frequency. That is the behavior of the Joule principle of particle and wave. So whenever now we are dealing with electromagnetic waves, know that we are dealing with particles. Now we change the formula, we treat that particle using that formula. That is the difference. If it behaves like a wave, V is equals to F1 lambda. Okay. Describe how electromagnetic waves propagate. How do we describe that?
I say I did not understand this question.
Describe how an electromagnetic wave propagates. An electromagnetic wave propagates.
I can't understand, sir.
The propagation, remember for when, what is it? When we're talking of ultrasound or waves in the longitudinal ones, the propagation was the disturbance, isn't it? Where we are moving up and down. You are moving your hand up and down, isn't it? Or either you are moving the string of a guitar down. Isn't the string of a guitar, the propagation, you are moving it down?
Yes, sir.
The string of the guitar. And for a spring which causes longitudinal waves, you are compressing the spring. Can you see the propagation? When you compress. So when you propagate, what is the disturbance that you are putting? The disturbance, the spring. You are compressing the spring. Can you see? So in terms of electromagnetic waves, now they are saying, yeah, how do you propagate these electromagnetic waves? In other words, describe how an electromagnetic wave propagates, which is 5.1. Let's give
I can understand.
Proper definition. Maybe you can understand, so that you don't waste time. Five point one. This is an electromagnetic wave. They are saying an electric field oscillating in one, an electric field oscillating in one plane produces a magnetic field. So an electric field oscillating in one plane. So in a plane, this is a plane. So we are having an electric field oscillating in one plane, produces a magnetic field. Remember magnetic field and magnetic field lines. You know, when you're doing charges, positive and negative, you have magnetic field lines, isn't it?
Yes, sir.
Whereby it's always away from the what? Positive and towards the what?
The negative.
Always, the field lines. So in similar fashion, that's what they're saying. They're saying an electric, how does it, an electromagnetic wave propagates? So an electric field which is oscillating in one plane, something that is plane, we are just talking of something that is flat. So if it's oscillating in one plane, produces a magnetic field. Oscillating in a plane at right angles, which produces an oscillating electric field, and so on. So in other words, the key points which they are just referring to is that these electric fields are, how do we produce the electromagnetic wave? We must have an oscillating electric field first, which is oscillating in one plane, producing a magnetic what? Field. And also that oscillating plane is at right angles. So these are the key things that we are talking about, which produces an electric field. This is what is produced during that oscillation at the right angles. So key points are here at the right angles, and it's an electric field that is oscillating in also one plane. So these are your key marking points for 3 marks. So you must just memorize, you remember. Just memorize, remember that.
Yes,
I
sir.
gave you the solutions. Did I give you the answer?
Yes, sir.
Yes, revise it again. Those are the key marking points. Revise it again. Check, 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 check. Definitions, you just have to remember the key points, how it propagates. Key points must be one plane and it's an electric field which is oscillating in one plane, and also we are talking at the angle of right angle, 90 degrees.
Yes, sir.
All right. So describe the relationship between frequency and energy of an electromagnetic wave as shown in the table above. Let's go. The relationship. So we want the relationship between frequency and energy of an electromagnetic wave. So let's go to our table. E and F. E and F. If the energy increases, what is happening to the frequency?
It also increases.
But when a number is multiplied by 10 to the power negative, this number is very small, isn't it? You know, this is very small, negative 24. So this number is big. So in other words, your energy is now increasing. Can you see? And
Yes.
if your energy is increasing, what is happening to the frequency? The frequency is also what?
Increasing.
Increasing. Because 10 to the power 14 is bigger than 10 to the power negative 24. So your answer there, what is the relationship? What can you say?
If the energy is increasing, the frequency also increases.
If energy increases, the frequency also increases. That's what
Yes,
they are
sir.
saying. That's right. And then on their model answer, they are saying you are correct. As the frequency increases, the energy of the electromagnetic wave increases. That's what you are supposed to do. That's when they say energy is behaving like a particle, we are using this formula which I gave you. E is equals to H1 F, where
F.
H the Planck's constant. You must know it. H is your Planck's
Constant.
constant, which is H. And C was the speed of light. So we must know that. C is representing speed of
Light.
light. So in this case, first, the tricky part was for you to identify which one number is big. So most students, they will see 10 to the power negative 24, 10 to the power negative 20. So then they say, no, energy is what? Increasing. Then they get a wrong answer of inverse proportional. So the trick, they know that this is big. Negative 14 is bigger than negative 24 because of the number line. Negative is on the left, 24 on the left, then negative 14 is bigger than the other from our knowledge of integers. Okay. So the relationship you said, when energy increases, frequency what? Increases, which is directly what? Proportional. So now they are saying frequency of wave E. They want the frequency of wave E. What is the frequency of wave E? Number 5.4. Frequency of wave E.
Wave. So I can't see wave E.
You can see?
Wave E.
Yes, wave E. There's no wave E. At the second. But obviously they are looking for F. It should be F. Where there was E, it should be F. It should be F. Here it should be F. Because it should be something like this. Maybe it's a mistake of the paper. Like this is A, then this is your B, C, this is E. Then this should be wave number E. Instead of F. So let's just correct it there. So that is the wave which they are referring to. Maybe it's a typing mistake. F, what is the frequency of wave? So you have your energy. Now it's a matter of playing around with the formula. What is your energy? Energy is what?
To HF.
Yes. So first you write E is equals to HF. That is the first point. E is equals to HF. So you write your formula. E is equals to HF. So that E, what is that E in terms of our formula here, in terms of joules? 4,97 times 10 to the power
-14.
You write it down. So our E, so you write 4,97 times 10 to the power -14 is equals to, what is the Planck's constant? It's given. This one you don't memorize. Planck constant is given. When you're given a question paper, you check the summary sheet, the formulas. This one. Can you see a Planck's constant?
Yes, sir.
There on the formula sheet at the back of the question paper. So the Planck's constant, it's 6,63 times 10 to the power -34.
84.
Then you write it down in the calculation. So we say our Planck's constant is 6,63 times 10 to the power -34 multiplied by F, which you are looking for. So if I want F, which means I divide both sides by what? Is it -34 or 24? Negative 10 to the power -34. Yeah, correct. -34. So let's punch. What are you getting? Hello? Are you still there?